distribution. Distribution is about multiplication. And we talked about distribution in this way. For instance, let's use this first example. It says 3 times x plus 1. So what we're going to do is we're going to distribute. We're going to multiply this 3 across this parenthesis, which means I'm going to take 3 and multiply it times 1x. 3 times 1x is 3x plus 3 times 1, which is 3. This is called distribution, and we use it quite a bit in algebra. So let's give it a shot. Our next one, 4 times x plus 4. So let's rewrite. 4 times x, 4x. 4 times positive 4, positive 16. Let's try another. Look at this guy. 7 times 3x, 21x. 7 times negative 5, negative 35. Do you see how I did that? Now, could you have said it differently? Sure, you could. There's many different ways to talk about this, but just try to stay consistent how you're doing things or saying things. So 7 times positive 3, 21x. Now, I could have said minus 7 times 5, 35. Now, however you say these, or however you see them in your mind, just remember to stay consistent. I try to teach this as a negative 5 because I want to see them as separates, as individuals, where the 3x is separate from the minus 5 or negative 5. Let's continue to go. Oh, look at this guy. This is negative 3. So as you distribute, remember to say that, or to remember that. Negative 3 times 2x, negative 6x. Now, it applies here. Negative 3 times positive 4, negative 12. Now, could you have written that differently? Sure you can. Sure you can. Could you have said negative 3 times positive 2x, negative 6x? Now watch. Could you have written plus? Yes. Could you have said negative 3 times positive 4 and written that as a negative 12? Yes. So both of these are the same. I don't want you to get too confused about that. There is two different ways to write this, and that's okay. Now, let's come down here where students kind of make many mistakes. That's with these. So this, remember this? Let me demonstrate again what this means. This is the same as saying me saying 3 times 2 times 3. And if you said that, if I wrote it like that, you'd be like, wait a minute, Darren. 2 times 3, wouldn't I take this, multiply it times that 3? And I'd say yes. So what I'm looking at is I'm multiplying 2 3s together. Now, that probably confused you and confused me. But here we go, let's try this again. So if I say, hey, let's take this x, and we're going to multiply it times 2x. Now, because this number and this number are the same, they're going to square up. So we're going to say 2 times x to the power of 2. Let me show you, demonstrate a different way. The first example, if I show you x times x, remember in the previous example, that's the same number times the same number. And if you're showing the same number times the same number, isn't that's that same number squared? Yes, it is. 3 times 3 is 9, and it's the same as 3 squared, which is also 9. These are the same. So it makes complete sense why x times x is going to be x squared. Although I don't know what that number is, it's the same number times itself. So that is what an exponent means. And that's what's happening over here. So x times negative 3x is negative 3x squared. Let's try the next one. X times 4x. 4x squared. Now keep going. X times positive 1x, or positive 1. You would say plus. Now, if you want to say 1x, that's fine. Most of the time it's written like this, and that would be the same thing. These two things are the same, though this is more common on the test, the way they write.